All right. This next section here, this is calculating sample size. So in a lot of the examples that you've seen up till now, a lot of the problems and the homework questions you've had, they've all said, oh, take this sample of size 25, or a survey was done and it included a survey of 100 people. Um, you know, 34 black bears were trapped. You know, you've been kind of told all these sample sizes. But how do you determine what sample size to use? How do researchers know that they need to trap, 16 bears or 100 bears or 500 bears or, political pollsters want to conduct a poll to see who is going to vote for who in the next election. How many people should they survey? 100, 1,000, 10,000, what? And being able to determine that number, is going to give you kind of an estimate of how much it's going to cost to conduct that survey and be within the constraints or the requirements of your project or the outcomes you're looking for. So being able to calculate sample size is really important. So here's a simple equation to introduce you to how sample size can initially be calculated. So, a student, professor, or researcher planning a study who wants a specified confidence level and margin of error can use the following equation. So if we know the confidence level, okay, that will let us calculate a Z alpha 2 score. And if we know a margin of error that we want, then we can plug that in here. And the last bit of information that we need is we need to know what the population standard deviation is. So this also has to be known. But this confidence level is what you want. So, you decide what confidence level you want. Margin of error, you decide what that is. The only thing you kind of need to know ahead of time is you do need to know maybe what you expect or what you know about the population standard deviation. So in problems, this will be given to you. Um, and I mean, in truth, for your homework, these things are going to be given to you as well. But, these are things that you as a person can decide, what's going to be good enough. And once you know everything on the right-hand side of this equation, then you can simplify it, and that'll give you a sample size. Now, when you calculate the sample size, you want to make sure that you always round up. Okay, so that means if you had calculated a sample size of 37.1, that would get rounded up to 38. So even though your algebra past experience in algebra would tell you, oh, so this is a 0.1, that means I need to round this down to 37. Okay, you need to go against that training and realize that when you're calculating sample size, you always want to round up. And the reason why you want to round up is you want to be conservative. Okay. If you were to round down in this case, you're going to be coming out either with too high a margin of error or a too low Z alpha 2 score that isn't going to properly reflect the confidence level or the margin of error that you originally want or that you decided at a minimum. So if you end up rounding up, that means you're going to be dealing with a confidence level that's a little higher, or a margin of error that's a little lower. Okay. And that's a more conservative estimate. And that's kind of what you want to be, is you want to be a little more conservative. You want to be a little more careful. So that's why you always want to round up. All right. So let's take this idea and this equation, and let's look at an example. All right. So calculate sample size when the population standard deviation is known. The population standard deviation for the age of Foothill College students is 15 years. If we want to be 95% confident that the sample mean age is within 2 years of the true population mean age of Foothill College students, how many randomly selected Foothill College students must be surveyed? All right. So, you know, I know kind of like usually math students' least favorite problems to do are word problems. Unfortunately, most of the problems in statistics are word problems. Okay. So let's look at this word problem and let's see how we can kind of carve this up in order to extract as much information as we can. And for that to kind of tell us or lead us where we need to go. So here we're told that the population standard deviation, so right away that is telling me sigma, for the age of Foothill College students is 15 years. So the word is means equals 15 years. So the given information that we've got is that sigma is equal to 15. Okay, and knowing the population standard deviation is what we need in this sample size equation. All right. Let's see here. If we want to be 95% confident, so that means we're going to have a confidence level of 0.95. And let's right now just go ahead and say, well, that's going to infer a significance level of 0.05, right? 95% plus 5% is 100%. And because we're constructing confidence intervals, we're going to be dealing with a two-tailed distribution. So we might as well take the significance level and divide it into two tails. So 0.05 divided by 2 is going to be 0.025. Okay, so we're going to need that. Okay, so if we want to be 95% confident that the sample mean age is within 2 years of the true population mean age. So this within 2 years, that is your margin of error. So we want to make sure that when we conduct this survey, that we're surveying enough students that that we're going to get opinions for students that are within 2 years of the average age of students when we conduct this survey. So either 2 years older or 2 years younger. Okay. Now, if we wanted that to be a little tighter, maybe we wanted only plus and minus 1 year. We want to conduct a survey where the student's age is going to be closer to the average age. And we decide, no, we don't want this to be 2 years, within 2 years of the average age. We want it to be within 1 year. We can do that too, right? We can even be a little more liberal about it and say, well, plus and minus 5 years is going to be fine. But that's just a decision we get to make. We get to arbitrarily say we want this to be 2. Okay. Just like this confidence level. We want a 95% confidence level, um, as part of determining our sample size. That's purely decided by the researcher, by us. The only thing we don't get to choose is we don't get to choose our own reality And if reality tells us that the standard deviation of the population of ages of students at this college is 15 years, it's 15 years. You don't get to choose what that is. Okay. All right. So this within 2 years is kind of hidden, but it's referring to the margin of error. Now, how many randomly selected Foothill College students must be surveyed? That's saying, what is our sample size? Sample size is what? So we have to calculate n. So let's say what we need is we need sample size. And to calculate sample size, we need each of these components here. So what we need is we need a Z alpha 2 score, we need sigma, and we need error. And once we get that as a fraction, we need to square that fraction. We need to square that value. All right, I'm already kind of thinking ahead, and I'm going to kind of do something cool, I think, with the calculator. But let me just wait. Okay. So what's nice is that in this equation, sigma, we've already got it. E, we've already got it. The only thing we don't have is we don't have this Z alpha 2 score yet. Right? We need that. So we get that from our normal distribution. And I'm going to do it off to the side because I want to take this equation and I want to work on it going down. Okay, so I think I'll have just enough room off to the side here to do a little normal distribution. It's going to be two-tailed because we're doing confidence intervals. The confidence level is equal to 0.95. So this area between those two critical values, this is our positive Z critical value. There's our negative Z critical value. And the area in each tail is the significance level divided by 2, which is 0.025. That's that area. And on this side, it's 0.025. That's the area in that tail. All right, good. So the Z alpha 2 score we need is positive. So I'm going to try and calculate this critical score here because it's already positive. Okay. Yeah. So let's go ahead and do that. So we're going to be using the inverse norm function. So we're going to have an area of 0.025, mean of 0, standard deviation of 1 on the right. So by choosing on the right, we're going to have a positive z-score. With the numWorks calculator, mean of 0, standard deviation of 1, area to the right, and an area of 0.025. All right. So let's do that really quick. Let's turn that back on. And let me clear what I've got there. Okay, second, vars, inverse norm. Area is 0.025, 0 and 1, to the right. And paste. Then enter. All right, now what I'm going to do is I'm going to store this into variable z. So I'm going to hit store, and then letter Z, I now need to hit the alpha key, the green alpha key, so then I can put Z there. Okay, so I'm storing that value into variable Z on the calculator to match the Z score. All right, and then with the numWorks calculator, let me backtrack. Okay, so I want to go to the distributions app, go to the normal mean and standard deviation of 0 and 1. Click OK. I want the area to the right, like that, and an area of 0.025. Okay, there's my Z critical value, right? That looks about right. And I want to store this. So notice that there's uh, an orange arrow to the right in this key, the X to the Y key. So I'm making sure that this value is selected, Shift, arrow. So I'm going to store this into capital letter Z. So to get a capital letter, I need to hit Shift, Alpha, then the plus button, and it'll print a little Z there. Hit execute. Okay, looks good so far. Um, all right, so what did I say? Was that, I just stored those values. 1.96. Okay, so I'm just going to write in here that our Z critical value is 1.96. So now let's go ahead and say, well, our sample size is going to be equal to 1.96 times 15 divided by our margin of error, which is 2, and we're going to square that. But let me show you something. Um, so this is a little bit overkill, but let me show you something here. So we have a standard deviation of 15. So I'm going to take 15 and I'm going to store that into capital letter O, because that looks like the sigma symbol. Okay, so that's in there. The NumWorks calculator, let me do the same thing. So I need to get out of this and click Home. I'm going to go to Calculation, and I'm going to put 15, store that. Capital letter O is on the number 9 key, so Shift Alpha 9, like that. Okay, and then our margin of error is 2, so I'm going to put the value 2 in variable E. So 2, I'm going to put into capital letter E. And on the NumWorks, I take the 2 and also put that in capital letter E, like that. All right. So now I'm really kind of primed to go ahead and calculate the sample size. So it's going to be Z times O divided by E and all of that squared. So I'm going to put it in there with letters. Okay, so I need to put a left parentheses because I'm going to be putting a squared on the outside. And I want to make sure I multiply the numerators first. Just want to be in the habit of doing that. So I'm going to have Z times O. So that's what's in the numerator, divided by the error, and all of that squared. Okay. On the NumWorks calculator, so I'm going to do something very similar. So I'm going to hit parentheses twice and Shift Alpha Z times Shift Alpha O. All right, and that's everything in my numerator divided by Shift Alpha E. And then I'm going to hit the right so I can put parentheses again, and I want to square that. So what's kind of neat about doing it this way is now you can see that the formula that we're putting into the calculator really does match the original formula, right? Z times O divided by E, and all of that is being squared, right? So here we are with both of these. So now I can hit execute and I can hit enter, and you can see I get the same answer. So 216.08 and some change. Okay. So N is equal to 216.08, and it keeps going. Now remember the rule. The rule is that you round up. So because we have something here in the decimal, we have some decimal places of accuracy here. We want to make sure that we round that up. Okay, so we're going to have n equals, we're going to round that up to 217. So the sample size that we need to have a confidence level of 95% and a margin of error of 2 is we need a sample size of 217, okay, to be safe. So we can kind of write that here in context. We can say sample size needs to be at least 217 students to have a 95% confidence level with a margin of error of 2 years. And there we go. All right. So, this was a good little problem, but it was good to maybe just introduce you, to how you can use the calculator a little bit better or in a different way, maybe to, enter in entire functions as accurately as possible without rounding any of the numbers, and to make it so that it's easier to see what it is that you're putting into the calculator. Okay. So you can see here I put in the value into Z, into O, and into E. And here you can see that I put the value O into E. You can't quite see Z, but if I wanted to check and see what was in Z, I could have just done Shift Alpha Z and hit Enter, and it tells me the value that's in it. Same thing with the Texas Instruments. If I just put the letter Z there, it would tell me what was in it. Okay. So you can always double check that whenever you need. All right. Let me know if you have any questions. See you in the next video.